Welcome to our deep dive, and today we're looking into the world's strongest bridges.
Strongest bridges, right?
Yeah, so you might think strongest is pretty straightforward.
Yeah.
Like, oh, that one can hold the most weight.
Right.
But when it comes to these incredible structures, it's actually a lot more complicated
Absolutely.
than you might think.
It's not just about sheer size
Right.
or even how much weight a bridge can hold.
Okay.
Our source material actually dives into three main criteria for judging a bridge's strength.
Okay, let's hear them.
You've got load-bearing capacity, of course.
Okay.
Structural integrity.
Okay.
And then durability.
So that means we need to consider how much weight they can handle,
Yes.
how well they resist stress and deformation,
Exactly.
and how they hold up against time and the elements.
That's right. The wear and tear.
Okay, so we've got our criteria,
Yes.
and our source provides a list of 10 bridges that kind of fit the bill.
Mm-hmm.
But rather than just going through them one by one, we're going to explore a few that really showcase these different aspects of strength in some really fascinating ways.
Absolutely.
Are you ready to jump in?
Let's do it.
Okay, let's start with something that might blow your mind. Sheer scale.
Okay.
So imagine a bridge so long it stretches over 100 miles.
Wow.
That's the reality of the Danyang-Kushan Grand Bridge.
It's hard to imagine.
It really is.
Yeah.
And not far behind it is the Tianjin Grand Bridge,
Mm-hmm.
both located in China.
Impressive.
They're the top two on the list,
Yeah.
and for good reason.
Yeah, they're massive.
It's hard to wrap my head around something that massive.
Right.
What kind of engineering goes into making a bridge that long even possible?
Well, both of these bridges are part of high-speed rail lines,
Wow.
which means they have to handle incredibly heavy trains
Yeah.
moving at extremely high speeds.
So to achieve that, engineers had to carefully consider all sorts of factors,
Yeah.
like the composition of the ground,
Right.
the materials used for construction, and the distribution of weight across that entire structure.
Absolutely.
It's crucial.
Think about it.
Yeah.
A slight miscalculation could lead to catastrophic failure.
You don't want to be on that train.
No, you really don't.
No.
So these bridges are more than just long stretches of concrete.
Mm-hmm.
They're really testaments to precision
Yes.
and meticulous planning.
Absolutely. And engineering.
Yes, exactly.
When you think about building a viaduct like that,
Right.
it just requires immense load-bearing capabilities.
Yeah.
And some of the most incredible structural engineering you'll ever see.
Yeah.
And I mean, just imagine the workforce and coordination involved in something like that.
Oh my gosh, it's mind-boggling.
Really is.
Speaking of impressive feats of engineering,
Okay.
let's shift gears a little bit
Okay.
and look at bridges that are built to withstand some of nature's most powerful forces.
Okay. Interesting.
I'm talking about bridges that have to face down typhoons,
Yeah.
earthquakes,
Yeah.
everything in between.
The Great Seto Bridge in Japan comes to mind. Oh, tell me about this one.
So what's interesting about the Great Seto Bridge is that it's not a single bridge. It's a whole system of bridges connecting islands across the Seto Inland Sea.
So it's not just about the strength of the individual bridges, but the resilience of the whole network.
Exactly.
Wow.
Each bridge in that system has to be strong enough to handle its own loads.
Right.
And withstand those elements.
Yeah.
But the system as a whole needs to be designed in a way that ensures the stability and the functionality of the entire network,
Okay.
even if one part is impacted by a natural disaster.
Wow.
And on top of that, it carries both rail and road traffic.
Oh, wow.
So that adds another layer of complexity to the design and the construction.
Talk about a multitasking marvel.
Right.
It makes you realize just how much goes into making sure a bridge can handle the specific challenges
Yeah,
of its environment.
for sure.
Speaking of environments, let's move on to another Japanese bridge
Okay.
that's famous for its ability to withstand some seriously strong winds and earthquakes.
You must be thinking of the Akashi Kaikyo Bridge.
Is that the one with the longest suspension bridge span?
Yes, that's the one.
It looks almost impossibly delicate considering what it has to withstand.
Yeah, but don't let its appearance fool you.
Okay.
The Akashi Kaikyo Bridge utilizes some of the most cutting-edge design and materials
Oh, wow.
to achieve its incredible strength.
Like what?
So we're talking about high-tensile steel cables
Yeah.
that can resist enormous forces.
Right.
And the design incorporates special features like wind dampeners
Oh, wow.
to minimize the impact of strong winds.
So it's not just about being big and strong.
Right.
It's about being smart and adaptable.
Exactly.
You see, it seems like the engineers behind these bridges are constantly finding new ways to push the boundaries of what's possible.
They really are. And as we delve into more examples, you'll see that strength can manifest in some truly surprising and beautiful ways.
I can't wait.
Me too.
Yeah.
So, we've talked about bridges that are impressive for their size and those that are built to withstand nature's fury.
Right. Some crazy conditions.
Yeah, absolutely.
Yeah.
But some bridges are considered strong for a different reason.
Okay.
And that is their unique design.
Oh, okay.
Take the Mala Viaduct in France, for example.
Yes, the one that looks like it's floating across the clouds.
Exactly.
It's more than just a bridge. It's a work of art.
It really is.
Yeah.
And that elegant design is also incredibly strong.
Okay.
It's a cable-stayed bridge.
Okay.
Which means it uses a system of cables that run directly from the towers to the bridge deck.
Okay.
And this design allows for those incredibly long spans.
Yeah.
And it helps to distribute the weight of the bridge very efficiently.
So it's not just about brute strength.
Right.
It's about using that clever design
Yes.
to achieve both beauty and resilience.
Exactly. And that's what makes the Mala Viaduct so fascinating.
It really is.
It demonstrates that a bridge can be strong
Right.
and aesthetically pleasing at the same time.
I love that. Now, thinking about bridges built to withstand harsh conditions,
Okay.
the Confederation Bridge in Canada comes to mind.
Yes.
It's a multi-span beam bridge,
It is.
and it was designed to handle some serious ice flows and storms.
That's right. It's a perfect example of how engineers have to adapt their designs to the specific challenges of the environment.
Exactly.
So in this case, the bridge had to be strong enough to withstand the weight of ice forming on the structure during those harsh Canadian winters.
Right.
And the powerful winds and waves that can batter the coastline.
So it's about understanding those forces at play.
Yeah.
And designing a structure that can not only withstand them, but also remain functional throughout.
Exactly.
It's amazing how engineers can take all these factors into account.
It is.
Now let's talk about a bridge that's a little closer to home,
Okay.
and one that might surprise you to find on a list of the world's strongest bridges.
Oh, really?
The Golden Gate Bridge.
Okay.
I know, right?
Yeah. Yeah. I could see why that would be surprising.
So some people might wonder why a bridge built back in the 1930s
Right.
would be considered one of the strongest.
Yeah.
But the Golden Gate Bridge is a testament to the power of continuous maintenance
Okay.
and forward-thinking design.
It's amazing to think that it's still standing strong
It is.
after all these years
Yeah, especially considering all the traffic it has to endure.
and the seismic activity.
Oh, yeah, absolutely.
Yeah.
The Golden Gate Bridge was actually one of the first bridges to utilize certain types of steel,
Oh, really?
which made it incredibly durable for its time.
Okay.
And to ensure its longevity, it undergoes constant maintenance and upgrades.
Oh, wow.
In fact, they're constantly repainting it.
Oh,
to protect it from the corrosive, salty air of the San Francisco Bay.
it's like a living testament to the dedication and ingenuity of the people who built it.
Absolutely.
And continue to care for it.
Yeah, they're constantly working on it.
Yeah, it just goes to show that strength isn't just about that initial construction.
But it's about the ongoing commitment
Yes.
to preservation.
Preservation, absolutely.
Speaking of learning from the past,
Okay.
there are a couple of other bridges I think we should discuss.
Yeah, let's hear about them.
These examples highlight how sometimes strength comes from, well, learning from mistakes.
Oh, that's interesting.
Yeah,
So are we about to talk about some bridge failures?
we are.
Okay, I'm all ears.
Let's travel back to Canada for a moment
Okay.
and talk about the Quebec Bridge.
Okay.
This bridge has a history marked by tragic accidents during its construction,
Really?
which serves as a reminder that engineering on this scale doesn't come without risks.
That's a sobering thought.
Yeah.
What happened with the Quebec Bridge?
So the initial design of the Quebec Bridge wasn't able to handle the loads
Oh, no.
that it was supposed to carry,
Okay.
leading to 2 separate collapses during its construction.
Wow.
Yeah. But from those failures, engineers learned crucial lessons
Yeah.
about bridge design
Of course.
and the importance of rigorous testing and analysis.
And it makes sense.
Yeah. So it's a story of perseverance and learning from those setbacks to create something truly strong and enduring.
Yeah.
And speaking of learning from setbacks,
Okay.
let's talk about a bridge collapse that's probably one of the most famous in history.
Oh, which one?
The Tacoma Narrows Bridge.
Oh, the one they call Galloping Gertie?
Yes, because of the way it swayed in the wind.
Yeah, that's the one.
It's a stark reminder that even the most advanced engineering
Right.
can sometimes have unforeseen consequences.
Absolutely.
So the original Tacoma Narrows Bridge collapsed just a few months after it opened.
Wow.
Due to a phenomenon called aeroelastic flutter.
Aeroelastic flutter.
Yeah, essentially it means that the bridge's design didn't adequately account for the way wind could interact with its structure, causing it to oscillate and eventually collapse.
Wow, that's terrifying.
It is.
Yeah.
Yeah, it's a reminder that understanding the forces of nature is absolutely crucial.
Right.
When designing these structures.
Of course.
And the collapse of the Tacoma Narrows Bridge was a major turning point in the field of bridge engineering.
Okay.
Yeah, it led to a much deeper understanding of aerodynamics.
I see.
And the importance of wind tunnel testing in bridge design.
Yeah.
The new Tacoma Narrows Bridge, built in its place, incorporated these lessons.
Oh, okay.
Making it a symbol of how engineers learn from past mistakes to create safer and more resilient structures.
That's a great story.
It is.
Yeah.
So we've seen bridges that are strong because of their immense size.
Right.
And those that can stand up to nature's fury.
Yeah.
But it's also fascinating to see how bridges like the Golden Gate and the new Tacoma Narrows Bridge represent strength through their history.
Right.
And the lessons learned along the way.
Absolutely. And each of these bridges tells a unique story.
Yeah.
Of human ingenuity, perseverance.
Yeah.
And that ongoing quest to build stronger and more innovative structures.
That's a great way to put it, man. Yeah.
I'm really starting to see how strength can take on so many different forms.
Yeah.
When it comes to bridges. It's not just about the materials or the size.
Right.
It's about understanding the environment, adapting to challenges, and constantly pushing the boundaries of what's possible.
That's what engineering is all about.
It really is. It's incredible to think about how bridge design has evolved over time. And how these structures represent not just these engineering marvels, but also these historical milestones and testaments to human resilience.
It is pretty incredible.
It really is.
What's fascinating is that this evolution isn't slowing down at all.
Really?
Our source mentions that new bridge technologies and materials are being developed all the time, pushing the boundaries of what's possible even further.
So the bridges of tomorrow could be even more astounding than the ones we've talked about today.
Absolutely.
What kinds of innovations are we talking about here? Well, think about the growing need for sustainable infrastructure.
Okay, yeah.
So engineers are exploring the use of new eco-friendly materials and construction techniques that can minimize the environmental impact of bridge building.
So they're not just thinking about strength and durability,
right,
but also the long-term sustainability of these structures.
Exactly. And with climate change presenting new challenges, engineers are also focusing on building bridges that can withstand more extreme weather events.
Like what?
Stronger hurricanes, rising sea levels, that kind of thing.
So this means designing bridges that are not only structurally sound, but also adaptable and resilient in the face of a changing world.
Exactly.
It seems like strength in the future might not just be about physical capacity, but also about adaptability and resilience.
You've hit the nail on the head.
I try.
It's a challenge that calls for some innovative thinking, collaboration across disciplines, and a deep understanding of that complex interplay between human needs and the natural environment.
Wow, after diving into the world of these incredible bridges, I'm feeling really inspired by the ingenuity and determination of the people who design and build them.
It is inspiring.
It really is.
What's really exciting is that the future of bridge building is wide open.
I love that.
Who knows what incredible structures we'll see in the years to come.
Before we wrap up this deep dive,
okay,
let's leave our listeners with something to ponder.
I like it.
So imagine you're an engineer tasked with designing a bridge for the future.
Okay.
What kind of strength would you prioritize?
Interesting question.
Would you focus on sheer size and load capacity like the Danyang Kunshan Grand Bridge?
It's a big one.
It's a huge bridge. Or would you prioritize resilience against the elements, like the Akashi Kaikyo Bridge?
Yeah.
Maybe you'd be inspired by the Melau Viaduct and strive to create a bridge that's both strong and visually stunning.
That would be something.
It really would. Or perhaps you'd be drawn to the history of the Golden Gate Bridge and prioritize longevity and adaptability.
Yeah, it's a tough choice.
It really is.
The beauty of engineering is that it allows us to dream big, to push the boundaries of what's possible, and to create structures that not only serve a practical purpose, but also inspire awe and wonder.
Well, on that note,
Yeah.
We've reached the end of our deep dive into the world of the strongest bridges.
It's been a journey.
It really has. We've journeyed from China to Japan, France, and Canada, exploring these incredible feats of engineering that connect us all.
Absolutely.
We've seen how bridges can be strong through sheer size resilience against nature's forces, innovative design, and the lessons learned from past mistakes.
Absolutely. And we even got a glimpse into the future, where new technologies and materials promise even more astounding structures.
Thank you for joining us on this journey.
Yes, thank you for listening.
And we hope you've gained a new appreciation for the strength, ingenuity, and artistry embodied in the bridges that span our world.
Absolutely beautiful structures.
They really are.
Until next time, keep exploring, keep learning, and maybe even start dreaming up your own bridge for the future.
I love that.
Me too.